In this video, we're going to take a look at factoring using the distributive property. The distributive property has been used to multiply a polynomial by a monomial. It can also be used to express a polynomial in factored form. When we say factored form, we're referring to a product of one factor times another factor, so I'll be pointing that out throughout this video. Compare the two columns in the table below. So if we take a look here, I have 3 times a plus b. It's important to note that 3 is one of the factors and a plus b is the other factor. So in here I have 2 factors, 3 and then a plus b. When I multiply 3 times a plus 3 times b, I'm applying the distributive property and I'm ending up with 2 factors multiplied together, creating one sum, 3a plus 3b. X is a factor, y minus z is its own factor. So again, 2 factors, 1, 2. This would be what we would refer to as factored form. And then when I distribute, this is no longer factored form because it's not factors, this is a difference. So I have x times y minus x times z. On the factoring side, we can go from the sum and we can pull out a value. So in this case, I can pull out the value of 3 or the factor of 3. I pull that factor out front, leaving me with a plus b in parentheses. So again, reminder, this is factored form because it is made up of factor 1 times factor 2. This here is not factored form. This is our unfactored form or a distributive form, however you want to kind of refer to that. Let's go and look at example 1. Using the distributive property to factor, we are going to utilize what we did in the previous lesson of finding the GCF. The GCF of all of the terms in the polynomial is going to be our first factor in factored form. So looking at a, I have 12mn plus 80m squared. So the first thing I have to do is find the factor of 12 and 80 numerically. Our numerical factor between 12 and 80, the largest value I can pull out is then I'm going to look at the m's. I have an m here, an m, so I factor an m out. And then as far as the n goes, I got nothing. So that's going to be my first factor. That's my GCF that I've factored out. Now comes my parentheses, and what's going to go inside the parentheses is what I would have to multiply by in order to get that resulting original term. So 4 times what gives me 12? 3. M times what gives me m? 1. I'm not going to write that 1. And then I still need an n by my 3. So 4 times 3 is 12. And then the m times the n is mn. I'm going to add 4 times what gives me 80? 20. And then m times what gives me m squared? Another m. And that would be my factored form. Again, I have a factor of 4m, and I have a factor of 3n plus 20m. And what I'm looking for is, if I were to distribute this, would I get back to that resulting starting expression, or expression. Looking at b, I have 3 terms here to consider. I got to be really careful with this minus. So first let's look at 25, 40, and 15. Largest value I can pull out of all 3, or factor out of all 3 of those numbers, is 5. Now I look at the x. I can pull an x squared out, an x squared out, and an x squared out. So all together, I can pull an x squared. And then looking at the y to the third, y and y squared, this y dictates, so just one y. Parentheses, and I'm thinking 5x squared y times what gives me 25x to the 4th, y to the 3rd. Look at the number first. 5 times 5 gives me 25. X squared times x squared gives me x to the fourth. A reminder of my exponent rules: when I multiply powers that have the same base, I add their exponents. So 2 plus 2 is the 4. And then y times y to the second will give me y to the third. Carry this minus through. 5 times 8 gives me 40. X squared is already here, so I don't have to multiply it by anything. Y is already there, so I'm nothing else to do there. This plus sign gets carried down. 3 times 5 is 15. X squared, I already have it. And then y times what gives me y squared is y. And that would be my factored form. C, 7 and 18. I don't have a number I can factor out of both. So I'm going to move on to my a. A to the sixth, a to the second. So I can factor out an a to the second. For the b, I can pull a b to the third and a b to the third. So I got b to the third. And sometimes we won't have that numerical piece. Maybe we can just pull out a variable or factor out a variable. This leaves me with my 7, a to the fourth, 2 plus 4 is 6, and then b to the third times 1, so nothing there. Bring down my plus, a to the I bring down the 18, and then b to the fourth. And there's my factored form. Another way we can factor is by grouping. So in example 2, we're going to look at factor by grouping. 6ax plus 3ay plus 2bx plus by. A good indicator that we're going to factor by grouping is when we have when we have 4 terms. That's kind of what we're going to be looking at here. So factoring by grouping, the reason we would factor by grouping is we're going to look here and say, all right, there's nothing that I can factor out of all the terms. I'm kind of stuck. I can't pull out a 6, I can't pull out an A, I can't pull out a B, I can't pull out a Y. So what we do is we're going to group together terms that we could factor something out of. So in this case, what I could do is I could add parentheses here and parentheses here. Now, bear with me. If I look at just that first set of parentheses, I have 6ax plus 3ay. In there, I could factor out 3, and I can factor out a. If I do that, I'm left with 3 times 2, and then I bring down the x, plus here I have a y. So this is the factored form just of the grouping that I created in the first part. I'm going to add, so this is from this plus sign. I'm going to look at the second grouping that I've created, and from there I can pull out b. So b times 2x plus b times y. Now, if I look here, get my colors out for a second. Now I have this part in common in both terms. So what I'm going to do is I'm going to factor that out finally. So if I pull out 2x plus y as a factor, as the beginning, I'd be left with 3a plus b. And now I have my factored form. It looks a little different because I have binomials, but this is a factor and this is a factor. Let's go ahead and do this again with part B. So part B. Looking here, I got 4 terms. Going to be a good indicator for right now that we're going to be factoring by grouping. I can see if I group the first 2 together, I have a 4 and an M's going on, and if I group the second 2 together, I have 3's and N's, so I should be able to kind of do something similar. So I'm going to group here, and I'm going to group here. Looking at the first group, I can factor out a 4, and I can factor out an M. So both terms have a 4 and an M in common. So 4M. This leaves me with M. 4M times M is 4M squared plus N. 4M distributed to the N would be 4MN. Plus, so here's my, bring down my plus sign. I'm going to look here, I have my 3 that I can factor out, and I can factor out an N. So I have 3N left with M plus N. Now I have a common factor. I can pull that M plus N out, and that would leave me with 4M and plus 3N. So 4M plus 3N. Alright, looking at the last example, which should be C, but is labeled B. Go ahead and fix that. I have mx plus bx plus m plus b. My indicator that I might use grouping is I have 4 symbols here, and there's nothing in common amongst each one. So there's nothing I can pull out that would factor out of each term. Now, if I group mx and bx, so I put my parentheses around those 2, I can pull out an x. But if I group m and b, I have nothing in common. So what I'm actually going to do here is I'm going to rearrange these terms because they're all addition. And I know that if I put the m and x with the m, I could factor out an m. And if I have the bx by the b, I can factor out the b. So I'm going to go ahead and rearrange this. So it's going to be mx plus m plus bx plus b. Now, when I group, there's something in each group that I can factor out. In the first, it's m. So m leaves me with x plus m times 1 is m. And then this group, I can factor out the b, leaving me with x plus 1. Now I have that common factor in each term. If I pull that factor out, x plus 1, I'm left with m plus b. Now what I'd like for you to do is pause the video at this time and try problems 1 through 18, and then start the video and I'll have the answer key for you. Alright, if you haven't paused yet, go ahead and pause and continue the problems. And here I'm going to show you the answers. So go ahead and use that to answer any questions, the questions and think of anything you might need to review for tomorrow. And this is factoring using the distributive property.